Hello everyone, this is Aruna Devi S. I am an embedded systems intern at Emertxe. During my internship, I have worked on a washing machine simulation project. In this video, I'll be providing you guys with an overview of all the topics that I have learned through this internship and also take you through the project that I have worked on during my internship. Now let's look at the agenda of this video. So first, let's move on to the goals of this internship. To gain knowledge and practice on embedded C programming, to gain hands-on experience on embedded systems, to build real-world projects such as building a washing machine using microcontroller and C programming. Now, let's look at the topics that I have learned through embedded C programming. There were a lot of topics that were discussed in detail. I'll provide you guys with an overview of what those topics are. First, we learned about primitive data types in C, which are int, float, double, and character. Then we moved on to learning about modifiers, which are really important in embedded C programming. We learned the usage of various modifiers such as signed, unsigned, short, and long. And also, we learned about qualifiers such as const and volatile. Then we came to know about loops. Loops are nothing but the keywords that are used to repeat a particular set of instructions based on the condition and or until a condition is satisfied. It can be repeated for a fixed number of times or until a condition is valid. There are three types of loops, such as for, while, and do while. And also, we learned about jump statements. Jump statements are nothing but the statements that are used to take the control from one part or block of the code to another. We learned about the usages of various jump statements such as go to, break, and continue. Now, in our washing machine simulation project, we have to perform a specific function based on the washing program as well as the water level selected. So for this conditions, we have to have conditional statements and we have used if, and else and also switch case and default. And then we learned about storage classes such as auto, register, static, and extern. Extern is the most commonly used in my project, and extern is used for using a variable that is declared in another source file. And also we learned about derived data structures such as structs and unions, and also about user defined data types such as enums and type defs. Arrays are nothing but sequence of a data structure, which means the data structure can either be primitive data types or derived or user defined data types. The speciality of array is that every adjacent elements will have adjacent addresses be allocated in the memory also. And then pointers are used to point to a specific memory location. So if we can access the specific memory location, we can use that value and also modify that value in that particular memory location. And then we got to know about functions. A function is a reusable block of code which performs a specific job by executing the defined set of instructions. It can be called any number of times. It is modular, so it is easy to understand. And also, if there is an error while performing a specific action, we can find out which function is performing that action, and so we can debug it easily without having to move through the entire code. Then we learned about strings, which is nothing but sequence of characters, and it ends with a null character /0. Macros are widely used in embedded system programming. Macros are defined using hash defined director and are processed before the actual compilation begins. Using macros, we can define a name that gets replaced with a specific value throughout the program. Now let's look at the topics that I have learned under embedded systems. An embedded system is a combination of hardware and software which is intended to do a specific task. There are four types of embedded system based on the performance and functional requirements of the embedded systems. They are standalone, real-time, network, and mobile. Let me provide you a brief intro about these embedded systems. Standalone embedded systems. It operates independently without needing a host system such as a computer or external processor directly displaying data or making changes on the connected device. The input is received through ports in the form of analog or digital signals. After performing the required calculations and conversions, the output is shown on a connected device. Various examples are washing machines, mobile phones, and more. The second type of embedded systems is the real-time embedded systems. When an output is required at a particular time, real-time embedded systems can be used. This system is more suitable for tasks that has to be completed on time or when there is a deadline for a task. There are two types in this, which are soft and hard real-time embedded systems. Soft real-time embedded systems. In soft real-time systems, the focus is primarily on completing the tasks or processes. Meeting deadlines is not that critical in this system. The key requirement is that all tasks must eventually be completed. However, deadlines should still be met whenever possible to maintain system's performance. Example, audio system in a computer. Hard real-time embedded systems. In hard real-time systems, strict adherence to deadlines is crucial and must never be violated. Tasks must be executed correctly on the very first attempt without any delays. Timing constraints are absolute and must always be met. Example, aircraft control system. Network embedded systems. Network embedded systems involve programs operating within devices that are interconnected, typically managed by a microprocessor or microcontroller. These systems rely on networks which may be either local area network or wide area network. Office or tech park security systems are typical examples where devices are linked through a centralized network and managed collectively. The last type is mobile embedded systems. Mobile embedded systems refers to portable devices that operate using embedded technologies. Despite having limited memory and features, their ease of portability makes them widely useful and accessible. Example, laptops and calculators. So now let's look into the project requirements. This project focuses on simulating a washing machine using PixSimLab, aiming to replicate real-world washing machine functionality in a virtual environment. Using various switches in the keypad to do the operations on the washing machine. Using CLCD for displaying options and time left to complete the process. Using timers for tracking time left to complete the selected process. Using motor for representing the ongoing process and using the buzzer to indicate door status and program completion. Now let's move on to the tools that I have used in this internship. For this project, I have used three tools which are MPLAB X IDE, MPLAB XC8 compiler, and then PixSimLab. So MPLAB X IDE is the development environment in which I coded, and then using XC8 compiler, I compiled the code into a hex file and I fed that hex file or loaded that hex file in PixSimLab for simulation. MPLAB X IDE is a free cross-platform integrated development environment for programming PIC, DSPIC, AVR, and SAM microcontrollers. It provides powerful features like code editing, debugging, simulation, and project management, all within a user-friendly interface. XC8 compiler is a C compiler specifically for 8-bit PIC and ABR microcontrollers. It is optimized for high performance and supports integration with MPLAB X IDE for efficient code development and debugging. PICSIM Lab is a graphical simulator designed for simulating PIC microcontroller based circuits and interfacing them with real or virtual hardware. It allows users to test and debug embedded applications without physical hardware, supporting integration with compilers like MPLAB XC8. In this internship, I have not worked with physical um, hard, any physical peripherals. So I worked on this Pixim lab to provide a simulation of this microcontroller and all other peripherals. Let's look at the design and code selection. This is the block diagram for the simulation project that has been implemented. The left side of the microcontroller depicts all the inputs, and the right side contains how the outputs are displayed. So switches are primarily used for getting input from the user. Switch 5 is used for turning on the washing machine. Switch 6 is used for pausing or stopping the operation in the washing machine. Switch 4 is used for navigation. Navigation means navigating through the options or also moving from a page to another page. And then switch 1 is used for door, representing the door status, whether it is opened or closed. Now, the microcontroller that I have used is PIC16F877A microcontroller. For in the output side, CLCD is used for displaying all the contents such as washing programs, water levels, timings, and more. And then buzzer is used for depicting the door status as well as indicating when the program is completed. Motor is used for indicating the ongoing process in the washing machine. This is the pin diagram of the microcontroller PIC16F877A that I have used in this project. The PIC Genius board in Pixum Lab offers virtual components like buttons, LEDs, LCDs, and relays, which are essential for simulating a washing machine's control panel and operations. Pixum Lab provides reliable simulation for the PIC16F877A microcontroller, which has sufficient I/O pins, built-in timers, and ADC modules, perfect for handling the logic and sensor inputs required in a washing machine system. Let's look at the peripherals that are available in this microcontroller. It has three timers: timer 0, which is 8-bit timer; timer 1, which is a 16-bit timer; and timer 2 is a 8-bit timer with a built-in prescaler and postscaler, each serving different timing and counting purposes. These timers can operate as timers. It means that it can count the internal clock pulses, or it can work as counters, counting the external events, making them useful for delays, event counting, and PWM generation. Each timer includes prescaler options, allowing us to divide the input clock and adjust the timing interval, which is crucial for precise control in time-sensitive applications. The CLCD is typically interfaced with PIC16F877A using a 4-bit or 8-bit parallel communication mode via port B or port D, enabling efficient data and command transfer. The microcontroller with sufficient I/O pins and stable timing control using its timers makes it ideal for displaying messages, sensor values, or system status on the LCD in embedded applications like a washing machine interface. A digital keypad is commonly interfaced with this microcontroller using GPIO pins configured in a row column matrix, typically connected to port B or port D. The microcontroller uses a scanning algorithm to detect key presses by sending signals through the rows and reading inputs from the columns. It enables user interaction in embedded projects such as setting wash modes or timers in a washing machine project by capturing numeric or control inputs effectively. Now let's look at the implementation of this project. So this is how this project looks in MPLab XIDE. This is the project and these are the header files, each having a specific purpose, and also these are the source files having specific purposes. So main.c is the source file that contains the actual flow of the washing machine program, like changing from one operational mode to another, and also detecting the key presses and taking appropriate actions according to the key presses. The washing machine function definition source file contains all the functions that are called from the main.c. Some important functions are clear screen, washing program display, water level screen, and then set time. Set time is the most important one as it is the function that I have used to specify the time required for each combination of the washing program and the water level that are selected by the user. Washing machine header contains the um, function prototypes of all the functions. Main.h contains all the macros used in main.c. Digital keypad.h contains all the macros that are used for detecting key presses. Digital keypad.c contains the logic for detecting short presses, which are used to navigate the options available, and also to detect long presses, which are used to navigate from the present screen to the next screen by selecting a particular option. Timers.c is used to enable the timer and interrupt. ISO.c is used for implementing the actual counting logic. Now let's look at how the simulation is working. So this is how this washing machine simulation project looks like in Pixel Lab. This is PIC Genius board with PIC 16F877A microcontroller. I have set the clock frequency to be 20 megahertz and LCD screen to be 16 cross 4. So this is the microcontroller. These are the switch configurations, and this is the motor, this is the buzzer, and this is the CLCD screen. These are the tactile switches that we are going to use. So RB0 is the switch 1, RB1 is switch 2, and accordingly every other switch is mapped. So now let's look at the implementation simulation of this washing machine project. So let's press key 5, which is RB4. Now the screen is loaded. Now we have arrived at the washing program screen. In this project, I have about 12 washing programs, which is daily. So to navigate through these programs, we have to press switch 4, which is a short press. So daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, and aqua store. Now you can see that the program is again looping and starting from daily and heavy. So for this demo, let me choose heavy. Now we have to select the water level. Uh, I have coded for 5 water levels such as auto, low, medium, high, max. Similar to the washing program screen, the options again loop from the beginning as auto. So let me select auto for now. Now we can either start the operation now or go back to the washing program screen by pressing switch 6. Let me show you how switch 6 works. Now we have again reached at the washing program screen. Let me keep it as the same as heavy. Now let me change the water level to low. Now let me press switch 5 to start the operation. So the program is heavy and the time left is 43 seconds. Now you can see that the function is wash. Now we can pause by pressing switch 6. When paused, the timer passes and also the motor stops running. So when I press switch 5, both of them resume. You can see that the timer is working and also the motor is rotating. The function is wash. Now we can simulate the door open by holding RB0. Until I release the key, the buzzer will be on, showing that the door is open. Now you can see that the function is changed from wash to rinse. We have a specific percentage of time dedicated for washing and then a specific percentage for rinse, and similarly for spin. Now you can see that the rinse will change to spin. So once the program is completed, the buzzer will sound for 2 seconds to indicate that the program is completed. Now we will be provided with the washing program screen again. So this is the simulation of the project. So we have reached the conclusion. Through this internship, I was able to understand the importance of C programming in embedded systems, understand various types of embedded systems, and got to know where each type of embedded system should be used. Use various tools to implement a simulation of a washing machine using microcontroller PIC16F8778. Thank you.